Hey guys, we're going to finish off the introduction to the action potential by just quickly talking about what is known as refractory periods. So refractory periods, I'm just going to write it up here. It's a pretty important concept because it really dates back to, this simple understanding of an action potential, which is an action potential could either be occurring or could not be occurring. There's no in between. Could either, maybe a better word to say is fully. So it could either fully happen or not happen at all. It would not happen at all. And that's this, that's the, signature part of the action potential, that you either see it happening or you don't see it happening. There's no in between, or it's about to have an action potential and then it doesn't have an action potential. That's just not how it works. It's either you're going to see one or you're not going to see one. And another thing is you can only have one at a time. One at a time. Cells can't produce multiple action potentials at the same time. And this is a statement that introduces what we know as the refractory period. Obviously you're going to see 1,000 action potentials being aroused in like a second, right? So like one potential per millisecond rate. But I just saying this, it seems like, wow, it's going to take a long time to do action potentials. But this entire thing, whatever we're showing right now, or what we're visualizing, we're really visualizing it's like extremely slowed down. If you were to hear, say, an like an EEG of action potentials, you're not going to hear like individual snaps of action potentials as you might hear in, when you're learning about, the action potential. You're just going to hear a constant buzz. That's how fast action potentials actually happen. And the beauty of that is it's all governed by refractory periods, because, obviously you can't start or initiate an action potential while an action potential is already happening. So we're going to introduce two parts of this refractory period idea. We're going to have an absolute part, and we're going to have a relative. And just by the names of these two things, you can probably draw inferences about what it means. And like absolute means all of it, or like everything possible. Relative means compared to a certain sample. And I think now we should also just define what refractory periods are. So a refractory period is basically a time interval in which action potentials cannot happen. Why? Because an action potential is already occurring or it just finished occurring. So to better understand this idea, let's consider this analogy. I tried to, make up. Obviously, it's not like the best analogy, but let's say you were swinging on a playground. Okay, you were swinging on a playground. Like, this is a very great swing that I'm drawing here. And you're in this motion, right? You're oscillating like this. And while you're oscillating, or say while you're in that movement of going back, like in between your movement, someone pushes you forward. So first off, that person pushing you forward probably won't have enough force to overact your already motion going backwards. Second off, it's only going to slow down this motion. So because of that, what we're going to see is nothing's going to happen. Basically, there's no initialization. So here's just that's just kind of a pretty loosely defined analogy that I made to help out understanding the absolute, or like the refractory period. Let's now draw a graph. And as we know, the action potential looks like this. I'm just drawing it. We have it start, and it goes like that. And this is at -60. This goes up to E of NA. If you want to better understand what E of NA is and why that's the maximum of the action potential, go and check out the previous video. It explains that. So in this case, I'm just going to like section off what is the absolute refractory period and what is the relative refractory period. So this part is what is considered the absolute refractory period. And this part is what is considered the relative refractory period. So say we have another action potential that then occurs like that. So this would be considered the relative refractory period. And just to define it, the absolute refractory period is the period of time after this action potential has started, which would be over here, after it's been stimulated, to the moment that it's like, it's not impossible to create a second action potential, which would be about over here actually. So this is kind of misplaced, but this is the general idea where you can now begin another action potential, meaning one entire period has gone through. Now, relative refractory period is a specific relative period of time between two action potentials, and it measures really just the time in which a potential can be initiated. So in this amount of time, this potential can be initiated at any time. So for example, I know I drew this next action potential over here, but this could have very well happened over here. It could have been like that. It could have happened somewhere over here. So like that, the relative refractory period shows a relative amount of space or a relative interval in time after, one action potential has been initiated, in what time a second potential can be initiated. So that was just a quick overview of refractory periods and relative and absolute refractory periods. That's all I have for you this time. I think we're going to go into more action potential propagation and some more math related stuff for the next lesson. Stay tuned for that.